The Khafre Pyramid is one of the pyramids of Giza in Egypt. It was built by King Khafre, the fourth king of the Fourth Dynasty and the son of King Khufu. Located southwest of his father Khufu's pyramid, it stands at a height of 143.5 meters with each side measuring 215.5 meters in length and an incline angle of 53.10 degrees, but is now 136 meters tall. Situated at ground level, it was constructed over an area of 215 square meters and has two entrances on the northern side. It still retains some of its outer casing at the summit. It is shorter in height compared to his father Khufu's pyramid, which originally stood at 146.6 meters. It is the second largest pyramid at Giza and its ancient Egyptian name is Wer-Khafre, meaning Khafre is great. Inscriptions in the Wadi al-Jarf papyri revealed the name of the prince engineer Ankhaf as involved in the final stages of building both the Khufu and Khafre pyramids. Scholars believe that this prince was also overseeing the construction of King Khafre's pyramid and that Ankhaf was a half-brother to King Khufu, thus making him an uncle to King Khafre. Historians differ on the exact date of the pyramid's construction, but it was built during the period between 2559 and 2535 BCE. In today's video, we'll be discussing the size of the pyramid and its upper structure through the eyes of archaeologists who have delved into this pyramid. But please, subscribe to the channel and hit the notification bell to stay updated with all the latest content. And don't forget to share your thoughts in the comments and suggest topics you'd like us to cover in future videos. Let's begin our story about the Khafre Pyramid. Petrie's primary contribution to Khafre's pyramid was in establishing its dimensions. However, he regrettably did not conduct a comprehensive internal survey. Petrie provides the average length of the pyramid as 8,474.9 inches, 215.26 meters. Various scholars have suggested different intended cubit lengths, with some proposing 410 or 411 cubits as 213.2 or 213.72 meters, each offering varying reasons, which are beyond the scope of this guide. Petrie, based on various clues, estimates the pyramid's angle to be 53:10. This angle has been proposed to form a Pythagorean 3-4-5 triangle, and it also corresponds to an Egyptian sikid of 5 palms 1 digit. But what is the Egyptian sikid? Sikid is an ancient Egyptian term used to describe and measure the degree of slope or inclination of the faces of a square-based pyramid relative to the horizontal base level of the pyramid. The term sikid is the ancient Egyptian counterpart to the contemporary term slope or inclination. The sikid of a right pyramid is the inclination of any one of the four triangular faces to the horizontal plane of its base, and is measured as so many horizontal units per one vertical unit rise. It is thus a measure equivalent to our modern cotangent of the angle of slope. In general, the sikid of a pyramid is a kind of fraction, given as so many palms horizontally for each cubit of vertically, where 7 palm equal 1 cubit. The Egyptian word, sikid, is thus related to our modern word, gradient. The base of Khafre's pyramid differs from that of Khufu's pyramid in a significant aspect. While Khufu's pyramid features an exceptionally level platform for the first casing course, this is not the case with Khafre's pyramid. The first casing course of Khafre's pyramid is made of granite, with the granite blocks having varying heights at the vertical foot. Additionally, these blocks were placed on a rock foundation of varying heights to accommodate the differences in height among the casing stones. Excluding the vertical foot, Petrie estimates the vertical height of the granite course to be 1.05 meter from the top to the base of its slope. Since the casing foundation wasn't level due to the uneven height of the casing blocks, the top of the first course could be considered as the reference level for the pyramid. Lehner and Horus conducted measurements of the top of the first step of the core along a length of approximately 215 meters and found that the level differed by an average of only 3 centimeters. When we look at the south side, we can observe some of the remaining granite casing stones. The one closest to us exhibits a significant vertical foot, whereas the one further back displays a shallower foot. The gap between these two casing stones reveals a higher rock foundation compared to the visible portion of the foreground casing stone. The initial steps near the southwest corner are carved directly from the bedrock, rather than being constructed from masonry. Given the difficulty in cutting granite, it was more practical to align the top of the granite casing with the level of the core step and adjust the variable heights of the casing stones by carving into the softer limestone of the plateau. This image here shows the same two casing stones, but from a different angle. Here, the casing stone rests on its rock foundation, exhibiting a relatively shallow vertical foot. Adjacent to this vertical foot, the courtyard pavement would be laid. Due to the thickness of the pavement, its foundation would be lower compared to the foundation of the casing stones. Pyramid stated that in the northwest corner, the entire rock was flat, and therefore the paving here must have been of the same thickness as the vertical base of the casing. This resulted in a raised square of rock, which aided Pyramid in determining the dimensions of the pyramid. The granite casing stones varied in size, with some being quite long and serving as headers, extending back to meet the core without requiring backing stones. Others necessitated different solutions involving backing stones. Similar to the rock foundation for the casing, it was easier to shape the softer limestone backing stones to fit the irregular granite casing stones. When we look here, our viewpoint is directed along the northern facade, and in the foreground lies the northwest corner, hewn from bedrock. Here, we can discern the elevated foundation platform for the casing stones, confirming Pyramid's observation that at the northwest corner, the platforms for both casing and paving converge at a similar level. The leveled surface of the first step is prominent, alongside the extensive vertical expanse of the second step. Maraggiolio and Rinaldi utilize this feature to argue against the existence of a second course of granite. They assert that the straight vertical face of the second step extends for considerable distances, suggesting the use of blocks at these points not only of uniform height but also uniform depth. Achieving this uniformity with granite blocks is exceedingly difficult, if not nearly impossible. However, as evidenced by the granite casing observed at Menkauri's pyramid, the builders were fully capable of aligning courses of granite to the same height. Similar to Khafre's pyramid, the granite courses at Menkauri's have a height of approximately 1.05 meter, demonstrating that achieving uniformity in height was achievable. It seems that the builders used the top of the first step as their reference level for the pyramid, which was constructed partly of bedrock and masonry. This level appears to have been meticulously maintained around the pyramid on all four sides, featuring long stretches of vertical faces. This meticulous alignment may have been intended to provide sight lines for Here, we observe the western facade of the pyramid extending towards the northwest corner. Remarkably, the initial step on this side is entirely composed of bedrock. Throughout the images, there is a notable abundance of granite scattered around all sides, a fact highlighted by M&R, who remarked, "It should, however, be noted that the quantity of granite, either loose or fixed, now existing at the foot of the pyramid, is very great, which makes one think that only a small part of this stone was taken away and reused." This surplus of granite is somewhat perplexing considering the strenuous effort required to split granite. The technique for this can be observed on the casing stones here, where a groove is partially cut along the stone center, followed by the insertion of wedges at intervals to fracture the stone. Given the extensive evidence of this splitting method, one may wonder why there is such an abundance of granite scattered around the pyramid. Was there a reason why the stone robbers did not process the already split granite pieces, or were many of them deemed rejects? In this scene, many fractured pieces of granite have been reassembled against the core. This area is on the north face near the lower entrance. According to Lehner and Horus, only 5 granite casing stones remain intact around the entire base of the pyramid. So, a significant amount of granite has been subjected to the vandalism of stone robbers, yet a substantial quantity still surrounds the pyramid. Why wasn't the granite removed as it became available from the pyramid? It's difficult to imagine that the entire granite casing was split before removal, especially considering the considerable time required to work with such hard stone. A significant layer of limestone casing remains at the top of the pyramid, and in some places, modern piers have been built to support the casing. Petrie described the casing as follows. The upper part of the pyramid was cased with macadam limestone, of a rather different quality to that of the Great Pyramid. It is grayer, harder, more splintery, and of not such a regular and certain fracture. The robbing of the limestone casing is uncertain. Petrie found a coin of Sultan Hassan, 1347-1361, under the southeast corner, and as the mosque built by the Sultan was said to have been built with stones from the pyramid, it suggested that some stones were removed from the base of the pyramid. though Petrie mentions other early travelers from 1581 and 1591 who suggested that the casing largely remained intact, though Sandy's view of 1611 shows the current state of the structure. The casing stones at this level are understandably of smaller dimensions. Maraggiolio and Rinaldi state, the casing was laid in horizontal courses. The stones are not always of large dimensions and many are smaller than some of the local limestone blocks of the nucleus. Lenner and Horus made the following observation on the casing. Looking out across the whole expanse of casing, it is noticeable that the slabs are not in fact flush, but jut in and out by a few millimeters. One explanation might be that at this level the masons cut the slope into the blocks before they laid them in place and so the fit is not exact. Alternatively, the slabs might have shifted when people removed the casing further down. Another possibility to explain this observation is the theory put forward by the engineer Peter James, of thermal expansion. Basically, the casing is subject to a large variance in temperature. The sun can beat down at 40 degrees plus, and cool significantly at night. This cycle of expansion and contraction over the vast age of the structure gradually breaks down the joints, and as more dust and debris fill these joints, the natural outcome is for the stones to undergo thermal movement. Just below the intact casing, there is an irregular band that appears to be neater stepped core masonry, while the lower part of the pyramid presents a less organized appearance. Maraggiolio and Rinaldi describe this transition. Immediately under the surviving part of the casing, the nucleus is seen to be formed of regular, clearly marked masonry courses, which form as it were an actual flight of steps. Below this, what remains of the faces seems to be very much coarser, as if it had suffered more from the ravages of time. This, however, does not seem to be the case, and the irregular superficial layer is perhaps due to detritus or the remains of backing stones still in situ, while in the regular part these remains have fallen or been removed. Lenner and Horus provide further insight. This lower band of loose material might be taken for packing material between core and casing, still attached after the casing was ripped away. Indeed, in certain lights, the rubble appears to form irregular bands, thinly veiling the more regular stepped courses underneath. However, when we climb the corners of the pyramid, we can see that the irregular masonry appears to continue for some depth into the pyramid. They suggest that more regular masonry was fitted as they neared the top to enable better building control. Without closer inspection through climbing or the use of drones, it's challenging for a layperson to form a definitive opinion on this unusual feature. Perring described a square platform of about 2.6 meters left at the summit of the pyramid. Shallow sockets have been cut on the upper surviving stones to assist in bonding the next course of masonry, and it is likely that the missing pyramidion had a square protrusion to fit into one of these sockets left in the course below. If the current platform is indeed 5 cubits square, then the top of the pyramid would be 1.75 meters, which seems overly large for a pyramidion. Assuming a pyramidion with a height of 2 cubits, 1.05 meters, its base would be 1.57 meters, with a volume of 0.86 cubic meters. We do not know the material from which the pyramidion was made, but if we assume granite at a weight of 2,700 kilograms per cubic meter, then we are talking about a pyramidion weighing around 2.3 metric tons. Here view of the west side looking south shows some remaining paving. Maraggiolio and Rinaldi describe the paving as somewhat irregular in size and shape, with a thickness ranging between 30–45 centimeters. They were laid directly on the rock, with seats made in the rock to receive the paving. The stone enclosure wall has long been robbed. Maraggiolio and Rinaldi offer a description of how the wall may have appeared. The enclosure wall of the courtyard was built on foundations which varied in width from 3.25 to 3.60 meters. As far as may be seen to the north, east, south, and west, these foundations are all on rock, except in the southeast corner, where, as we have said, large blocks of local limestone appear on the surface. They also form the foundation of the southeast corner of the pyramid. Under the fine limestone blocks of the foundation of the enclosure wall was laid a thin layer of very hard and pink mortar, large traces of which are still visible on the leveled rock. We think that, as usual, the foundation was a little wider than the wall at the base, whose thickness, therefore, must have been about 3.14 meters. The wall itself would have been about 8 meters high. If we accept a pyramid with a base of 411 cubits or 213.7 meters and a height of 274 or 142.5 meters, Its volume amounts to 85% of that of the Great Pyramid because the Great Pyramid is 440 by 280 cubits or 229 meters base, 145.6 meters height, and if a 470 cubits or 244.4 meters base pyramid was intended with a 3-4-5 angle, the Great Pyramid would only amount to 78% of this giant. Pairing would give the base of Khafre's pyramid as being some 10.11 meters higher than Khufu's base, meaning that Khafre's summit would be higher than Khufu's by about 7 meters, based on a 411 cubits or 213.7 meters base. Here we've reached the end of today's video, but we're not done talking about the Khafre Pyramid. Join us in the next video where we'll delve into the pyramid's infrastructure, so stay tuned for more updates. Don't forget to like the channel and hit the notification bell to stay updated with all the latest content. Make sure to share your thoughts in the comments and suggest topics you'd like us to cover. See you next time.